So let's continue with our playlist. So before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is odd and even linked list. What is the problem stating? It is stating that you'll be given the head of the linked list and your task is to group the odd index nodes. What do you mean by odd index nodes? If I try to number them, then this is a odd index node, this is a odd index node, this is a odd index node. 1, 3, 5. So you have to group them together and you have to group the even index node together. So these are the even index node. You have to group the even index node together and then you have to return it. So basically what you have to do is, you'll have to group 1, then this is the odd, this is the odd, this is the odd. So after 1 you'll have 4, after 4 you'll have 5. That's done. So you've grouped all the odd index nodes. Right after that, you group all the even index nodes. So the even index node will go after that. Right after that, it will be 6. And then it will be null. So what I've done is, I've basically taken the odd index nodes at first. After that, I've taken the even index nodes and I've connected them. So a group of odd and then a group of even. Then you connect them. Once you have connected them, return the new head of the linked list. Return the new head of the linked list. This is what you have to return. So what if this problem comes up in an interview? You will be starting off with the extreme range solution, and what will be that? Data replacement. What do I mean by that? You have odd index nodes, right? These are the odd index nodes. And if you visualize the final linked list, these are at the front, these are at the front. So you'll take them, yes, you'll take them and you'll place it on the front. So basically you replace the data of the nodes in the first half. Once this is done, you will go through the even nodes. 3, 2, 6, 3, 2, 6. Then you'll do the data replacement in the second half. Once you have replaced the data, you can return the initial head and your linked list will be ready. It will not be reordered, but you will rearrange the data such that the data is in the rearranged state. Got it? How can I do that? What I will do is, I will take a list. I'll take a list and I'll start traversing. I'll take a temporary and I'll place it at the head. What is the first thing I need to do? I need to get the odd index data. So I'll start at the head and I'll jump it by 2 indexes. I'll jump it by 2 places, right? So the temp is standing at the head. I'll get the first data, which is 1. Once I've got that, I'll move the temporary to next of next 2 places. I'll get the next data. After that, again, I'll move it to the next of next. I'll take the next data. Once I've done this, temporary will reach null. Temporary will reach null. Once it has reached null, we will stop. So what I can say is, one iteration is done, but it did jump by 2 places. So technically, it just ended up taking n by 2 time because you're jumping by 2 places. The next iteration should be done to get the even index nodes. How can I do that? Maybe I'll place temporary at heads next because that is where the even index starts. Correct? Again, I'll take the data and I'll put it into the list. And then I'll again jump it by 2. I'll put the data into the list. I'll jump it by 2. After this, yes, you'll again put it. So when you try to jump, you will not be able to jump because there is a null. And if you say next of next, it doesn't exist. Nulls next doesn't exist. So you'll not be able to jump. So remember, whenever you reach the last node, you will have to stop. Got it? So what I've done is, I've got a list. I've got a list which has the odd and then the even index data. What is the next step? I'll have to go through the linked list again and replace it. This time what I'll do is, I will go through it. So I'll keep temporary placed at head. And I'll keep one more pointer I placed at the 0th index of the list. And I'll start traversing. Okay, I have 1. That's fine. Let's move temporary to the next. Let's move I to the next. That's 4. Let's replace it by 4. Move temporary and move I. Next we have 5. Replace it by 5. Move temporary and move I. Next we have 3. Replace it by 3. Move temporary and move I. Next we have 5. Replace it by 2. Move I. Move temporary. Next we have 6. Straight away replace it by 6. And then move temporary and move I. I will exceed the length of the list and temporary will reach null. This is when you stop. And if you carefully observe, data replacement has been done and this is your brute force solution. So let's quickly check out the pseudo code. Again, I'll be writing the pseudo code in case you want C++, Java, Python, JavaScript for the brute force. The link will be in the description. Make sure you check it out. So what is the first step? We need an array. So maybe let's assign the array to be an empty array. We need temporary, and first thing is take the odd index out. So let's place temporary at head. That was the first step. And what I will do is I'll keep the while condition empty. And what we will do is we'll go inside and say array.add or push back, whatever, depending on your language. And we will say temporary, can you give your data, a value, whatever is your struct's definition. Once you've done this, you will say temporary, can you move yourself? And since I am going to odd index, it will be a jump of 2. So temporary of next and next, it will jump. Perfect. Can you tell me what will be the while condition? I'm doing temporary. So this should definitely not be null because null of next, it will throw you an error. So temporary should definitely not be null. That's for sure. And what will be the other condition? I'm doing temporary next of next. So this should also not be null because if this is null, there's a problem. Null of next is not feasible. So what I'll do is temporary next is not equal to null. Perfect. Once I've done this, is it done? Is it done? Have I taken up? Is it done? Have I taken up all the odd index elements? The answer is no. I'll take an example. Imagine you have 1 that's pointing to 2 and that's pointing to 3 and it's pointing to null. And this is where your head stands at. So if you have temporary, what's the first step that will happen? It will go inside, adds the value 1, right? And then it will move temporary to temporary next of next. So temporary will go here when your array just has 1. When your array just has 1. This is what your array has. And when the temporary stands at the last node, very important to notice, when the temporary stands at the last node, this condition, temporary of next becomes null, isn't it? Temporaries of next is null. So it will never go inside. If it happens to be a odd length, linked list, it will end up missing the last element. So you will have to check if at the end of the day, yes, temporary was there. If it was not null, you will say array, can you please add that element? Because we might be skipping, because of this condition, we might end up skipping the last element. So this is how you can put up all the odd elements and the time complexity will be n by 2 because you're jumping twice. What is the next job? The next job is again repeating the same piece of code, but this time the temporary will be pointing to head of next because that is where we start off. Head of next. The same line of code. The exact same line of code. So I'll be like, while temporary is not null and temporary dot next is not null. I'll say array, can you please add temporary dot data, and can you say temporary, can you move to temporary dot next. So what this will do is this will take all the even index nodes. Why? Because you started with head next. Once this is done, again it might happen to be the last node. So if in case there is a last node, ask your array to add that last node, and that will be temporary of data. Perfect. That will be temporary of data. Once you have done this, it's done. What is the next job? Just go through the index. Index will be 0 and reassign temporary to head and start writing the code. So you say while temporary not null, and what you say is temporary, your data or value, whatever you can call it, equal to array of I. And once you have done this, you move I to the next index, and you say temporary, can you move to the next? So temporary says, why not? I'll move to the next. So it's like temporary dot next. Once it is done, it's gonna be, hey, can I return the head? Just make sure there is an edge case. The edge case is when you start off, you check if it's a single node. What if the head is to be null? If the head is null, or if it's a single element node. So if this is null, any of the cases, if that's the case, you will end up returning whatever is given to you. Single element or an empty linked list, you will not be doing anything. Otherwise, you end up performing this step. And again, the step, this is a BGO of n by 2. And this is another BGO of n because you're traversing through all the elements. So what will be the overall time complexity? Can I say the overall time complexity will be 2n? Yes, I can say. What will be the overall space complexity? Can I say that it will be BGO of n? Why? Because we're using an external data structure, an array to store all the elements. This is where the interviewer will be like, hey, I'm not happy with the external space that you're using. Can you please optimize it? So we need to optimize the space complexity of BGO of n, which technically means you're not allowed to use any external data structures. That gives a hint that, hey, whatever we need to do within the given linked list itself. So let's try to think in that direction. What is the final state that you need to return? It starts off with the head of the linked list because that's the first odd index node. Then you take the next odd index node. Then you take the next odd index node. And once you've done this, you start with the even index nodes. So that's basically 3, 4, and then 6. That's what you do. And 6 is pointing to null. And then you basically connect the last of odd to even, and you return the current head itself. You return the current head itself. That's what you do. So we need to do link changes in such a way that 2's next is pointing to 1, 1's next is pointing to 5. That's it. That will make sure that the odd is connected. Once you have done for the odd, the even 3 is connected to the even 4. The even index 4 is connected to the 6. Once this link change of odd and even is done, what is remaining? This 5, because 5 should connect to even starting. So make 5 connect to this 3. That's it. Just make 5 connect to this 3 and your job should be done. Right? So can I do the link changes? I think I can. So I need to find a logic, and the logic will be in 2 steps. The first is changing the links for the odd index nodes. The second is changing the links for the even index nodes. Correct? So what I'll do is I'll take odd, and it starts with the head because that is where the odd index starts. I will take even, I'll place it at head of next. I'll place it at head of next. Done. Let's try to change the links. For the odd, can I say this should ideally be pointing to the next odd, but it is pointing to 3, which I don't want. So what I will say is, hey odd, your next, can it point to odd's next of next? Can I say this? Because if I say this, then this next ends up pointing to this. It does. That's what I'll do. So I will basically change the link and point it to 1. Done. Right after that, you say odd, move to your next. And if I say next, now the next is this. So it moves. I've changed the link for odd. At the same time, simultaneously, I can do it for even as well. No need to do it after, like in one more loop. You can do it in the same loop. Let's do for the even. Can I say even, hey, your next is pointing to 1, which I don't want. I want it to point to 4. Can you do this? He'll be like, yes. I'll say even dot next. It should point to even dot next, isn't it? That's what it should be. So I'll straight away say, hey, instead of pointing it here, can you point it to 4? Like, why not? Sure. Done. After this, move the even to the even node. Perfect. Next step will be the same. You'll say odd. This is pointing to 4, which is wrong. Can you point to next of next, which is this? Perfect. Once you've done this, move the odd. Simultaneously do it for the even. even, this is wrong. So you should technically be pointing to 6 and the even reaches here. Right after this step, remember one thing, the even will always be ahead of odd. The even will always be in front of odd. So whatever checks you'll write, like whatever your last check is, should be based on even, And you're seeing that even is at last, you stop. Similarly, odd, you don't need to do anything, you stop. You have stopped. So once we have done the two phases, which is basically pointing the odd index nodes to the odd index nodes, pointing the even index nodes to the even index nodes. The next job we have to do. And the next job will be, I know I'll start off at 2, I'll go to 1, I'll go to 5, and that's my last odd. But this last odd cannot point to 6 because 6 is the last even. This 5 should technically point to 3 because in the real world, 2 should point to 1, 1 should point to 5, and 5 should point to 3, and then the even starts. Right? But the problem is 5 is pointing to 6. I still have to do a link change after those two phases. I'll have to do a link change. So I need to make sure 5 points to 3. But do you have access to 3? You cannot call it as head next. Can you call it? No. So remember, before starting, memorize this. Remember this in the memory. Memorize this. Remember this in a separate variable, even node, even head or whatever. And right after this, after your phases, you can say odds next should be, because odd is pointing to 5. This next should be pointing to even head. So what will happen is, this link will go off and this will be pointing to, if I have to, it will get messier, I know. It will be pointing to this. So basically, it goes like this, this, and this, 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 and this. Yes, arranged. Looks messy, but if you carefully look around, it has been arranged according to the question. So I'll be writing the pseudocode in case you want the C++, Java, Python, and JavaScript codes. The link will be in the description. Make sure you check it out. What do we need? We need an odd. We need an even. Where will the odd start? At the head. Where will the even start? Head of next. And where will the even head be? It's at the head next. So if you remember, we need to memorize even head so that it can be used for the linkage. Okay. Let's try to write down the while loop because we need to traverse. And I'll not write the condition. What's the first thing that we are doing? We're saying odd, your next should be pointing to odds next of next. Again, depending on language, it can be dot, it can be arrows. Right? That's done for odd. What about even? Even dot next equal to even dot next dot next. Once this is done, what is your next job? You say odd, can you go to your next? I'll be like odd dot next, that's it, because you've already pointed it to next. And you say even, it'll be even dot next of next. Done. Once this is done, I'll write the while loop condition. Once this is done, you say odd, wherever you're standing, your last should definitely be pointing to the even head. Now this line is for this one. Done. Once you've done, what will be your head? The initial head will be the head itself because that is where the odd starts from. And please make sure if the head is null or that means an empty linked list, or if it is a single element, you will not be doing any of these. You will not be doing any of this and you will be returning whatever is given to you. Whatever head is given to you. If it's an empty, it goes as null. If it is a single element linked list, it goes as a single element. So what will be the while condition? Will I just write for odd? Will I just write for even? Will I write for both? That is the question. Let's understand. We have two nodes, odd and even, rather 2 pointers which are traversing. Can I say one thing? If even has not reached the end, I repeat, if even has not reached the end, odd will also not reach. Why? Because even is bound to be in front of odd, right? If you see even is here, odd is below, previous to it. If even is here, odd will also not reach null. So if I can determine when even, for even if I'm sure it is not, it hasn't reached null, that's it. That's my job. So what I'll do is I'll try to determine if even has reached or not. If it hasn't reached, odd will also not reach, and I can do the operations. So let's analyze. What am I writing? Even dot something. So this definitely cannot be null. This definitely cannot be null. For sure, let's write it. So even definitely cannot be null. That's for sure. I'm again doing even dot next. So this also cannot be null because null of next will throw a null pointer. So even dot next also cannot be null. Simple way to analyze. You don't need to check for this because if even dot next is null, that basically means even is null. So you don't need to check for anything else. If you just check for this and this, that will work. Remember one thing, even if you reach the end, in case of odd number of indexes, wherever odd ends, that's the correct position. So you might be thinking, hey, you've just written for even. Even is reaching the end, right? What if odd hasn't? You might think that, right? Let's take an example. You're taking odd to be here. You're taking even to be here, right? What are we doing? We're saying odd, point this to this, and then odd moves here. And then you're saying even, point this to this, and then even moves here. And this is when you stop. You say even, you are the last node, right? Because even dot next is null. You're the last node. So stop, no need to do. And we carefully observe, if this stops, you're at the correct place for odd. You're at the correct place. So if you're just doing for even, this will work out. No need to think. So what will be the time complexity of this portion of code? What I'll ask you is, please think about it and write it in the comment section. I want to see what you are thinking, okay? And after that, hear me out. So if you remember, in the brute force, we first wrote a while loop to separate the odd elements to an array. And that while loop was taking bgo of n by 2. And then we went on to write another while loop to separate the even elements that was taking n by 2. And both together added up took bgo of n to segregate them into an array, right? Over here, what I've done is, it's a single while loop. But I'm doing the odd and the even operations together. I'm doing it together simultaneously. So technically the while loop is running for 1, 2, 3, which is basically n by 2 times. Not more than that. It's basically running for n by 2 times. Okay. So if it is running for n by 2 times, can I say that the time complexity is n by 2? Maybe yes, but you cannot. You need to compute these unit operations. You're doing 2 steps. Like, they need to be computed as 2 steps because you're doing 2 operations, 2 link changes. So it's basically bgo of n by 2 into 2, which boils down to bgo of n itself. So this will be the time complexity. Now this will be slightly faster than doing it in 2 while loops. Slightly. Not a huge difference. Because if you write odd and even in 2 while loops, it will be of the similar time complexity, slightly greater. Slightly, not much. What about the space complexity? It's a bgo of 1. Just doing link changes. Nothing else. So if you're still watching, I'm very, very sure that you have understood everything. And if that is the case, please do comment understood. And please do consider giving us a like as well. If you're new to our channel, what are you waiting for? Hit that subscribe button right away. And with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.